This lecture is going to be sort of a check-in on units of analysis. So we're going to do a little bit of a review since units of analysis also come into sampling, because sampling is usually when we're sampling, we're getting our dependent variable as well as the demographic in which that dependent variable is connected to. So I'll give you sort of a primer on sampling and how units of analysis are connected to sampling. But we talked about units of analysis when we were talking about the stage and the research process of conceptualization and operationalization. And so we're also going to review it because it's relevant to sampling as well. So when we're doing a study and we're picking a certain demographic, or like, for example, if we want to study juvenile justice and we want to look at adolescents, teenagers who might be at risk because of trauma for crime, then we can't necessarily always find everyone in that demographic that we're interested in and collect data on them. It's just not feasible. Some people also might not consent to a study in which they do that. So can be difficult. Fortunately, we get some privacy within our government, but it's not like researchers, especially at universities, have unlimited resources to collect data from people. And so to get around that, we developed this process of sampling, which is selecting observations and getting data. And so this is where units of analysis come in, is this in the sample element. So it's the unit at which information is collected, and that provides the basis of analysis. So the sample element in itself is a unit of analysis. The other variables that you might be collecting data on are going to be in different units of analysis. So unit is basically like a gram or weight. It's the actual type of data that we're collecting and what it's measured in. And so sampling allows us, since we can't collect information on everyone within a data space, it allows us to create a frame in which we can generalize from. So some review on units of analysis. Sometimes we want to study individuals, right? So we may be sampling an entire police department or police within a specific district, or we might be sampling gang members within the state. And so there's individuals, remember, is a unit of analysis, and then there are groups. So we might be sampling people within a particular geographic area, like a city, or we could be sampling organizations like a courtroom work group, as we've talked about in prior lectures. There's a whole sort of working group that occurs in courts, so we might be sampling a work groups throughout the state, but we can't collect information on every single courtroom, right? That might not be feasible. So maybe we want to get a sample of courtrooms across the state. So we might have different strategies to ensure that the sample we have is representative of the larger population that we cannot get full access to. And we'll talk more about the different strategies for this, but I just want to review units of analysis because it's important when you're analyzing data to always think, okay, what are the units of analysis of my dependent variable? And what are the units of analysis of the independent variables that I'm looking into? And remember, independent variables are the ones that influence the dependent variable. So if we're asking a question like, how does wage disparities influence the courtroom work group? Maybe if there's large wage disparities, that creates more tension, right? So our unit of analysis for our sampling element would be an organization. We're studying work groups in itself, but our independent variable, wage disparity, is in maybe the amount, maybe it's a rate, right? So maybe it's the proportion of wage to another person, or maybe we're instead going to measure just wage in general and collect data on that. And then it's also a rate, it's how much an individual gets paid within the work group. And so we need to think about these variables because they affect our findings and the validity and generalizability we have in other areas. And then finally, recall that social artifacts are sort of any primary sources that you get. So newspapers, photographs, whatnot is another unit of analysis. So we're going to have like a little quiz here. And I'm going to sort of give you some research findings, and we're going to think about what the unit of analysis is. So compared to other immigrant receiving countries such as the UK and Canada, the US has respectively placed over 3 times as many individuals into detention and detained 11 times more immigrants on any given day. So what is the unit of analysis? I'll take a pause so you can think about it for a second, but this one's sort of an easier one. It's individuals. My transitions are not on here, so I will have to. Yeah, so it's A, individuals is the correct answer. The number of hours new officers spend in the classroom and field training was also compared. For classroom hours, the overall median for city departments was 488 hours. Campus departments requirements average 420 hours. The median number of field training hours for new officers was, and it goes on. So what is the unit of analysis in this instant? I'll take a pause. So this may be a little bit more difficult. The units of analysis in this finding are actually organizations, because we're talking about city departments and the amount of hours they have their officers spend in the classroom. So we're talking about the field training of these organizations, not necessarily the individuals within them, because we're not saying the average police officer gets 200 hours of training. Instead, we're saying that campus department requirements average around 420 hours. So sometimes units of analysis can be a little confusing. So really think and step back and break apart the sentence and the finding, because there's a lot of information in it. And sometimes our units of analysis, like organizations, are constructed of an individual. So this particular example could get a bit confusing because we're talking about departments, and obviously departments have individual police officers within them. But the unit of analysis, the sampling frame we're talking about, is department. So we're comparing campus departments versus city departments, right? And so you really want to be careful about what your units of analysis are, because you can't, after reading this, say, oh, you know, your average police officer gets 420 hours of training. That's not necessarily true. It's the requirements of the department that we're talking about. Alrighty, and in this article, we're talking about a larger concept, which is surveillance and system avoidance. And so she introduces, Sarah Brain is a criminal justice scholar who's pretty prevalent right now. And so she used AdHealth data and found that individuals who've been stopped by police, arrested, convicted, or incarcerated are less likely to interact with surveilling institutions, including medical, financial, labor market, and educational institutions, than counterparts who have not had criminal justice contact. By contrast, individuals with criminal justice contact are no less likely to participate in civic or religious institutions. So take a pause here and think about, what is the unit of analysis in this situation? So this is sort of the opposite of the last one. In the article, she's talking about system avoidance, so it might seem like a social artifact or an organization that's the unit of analysis, because system avoidance is not something that you necessarily think of an individual or a group when you think of something, but she's testing a concept that she's developed that's more abstract, and how she's actually measuring that concept is how individuals behave. So in this instance, A, individuals is the right answer. And we can see that in her finding, right? I find that individuals who have been stopped by police, arrested, convicted, or incarcerated are less likely. So likely is a big word that you're going to see in a lot of research articles. And that's when we're talking about the specific sample element and the unit of analysis attached to that. So if you see the word likely, then that means that your sample element and unit of analysis is not far away from that specific space. All right, so when we're talking about units of analysis, sometimes we want to have a finding or a takeaway that's descriptive so we can say what the average of that is. So in the past examples where we were talking about findings and the units of analysis, we were saying the average time of training is 420 hours, right? Or that people are less likely to do something, right? And so sometimes we want to just, usually when we're doing statistical analysis, we're talking about averages. But there are other measures of central tendency that we can use if we're not being quantitative and measuring things that are more numerical. So the mode is the most frequent attribute. So if we're dealing with categorical data like time in higher, not time in higher education, that would make it quantitative. But if we're talking about the amount of education earned, then if we're dealing with a demographic or sample element, we might report that the most frequent amount of higher education is a college degree in our sample. Most people had a college degree. So that's the most frequent attribute. That's when we're measuring the mode. Mean is the average. So in the example about departments, there was an average of 420 hours that was required for training. So that's a sum of all of the department's requirements averaged over. The median is the middle attribute if we rank the data. And so if we often don't do this in like quantitative spaces, because especially if we're dealing with intervals or ratios, because there's so many ranges, and actually spacing all of those things out might not be the most ideal. We might do this in a variable that is more ranked, and we'll get into more specifics. I have a visual in a second. Now, before I get into the visual, I just wanted to review the two aspects of variables that need to occur is mutually exclusive and exhaustive. And so last year I had students give me examples of what mutually exclusive meant to them. And so here are their examples, which might be helpful as you review. So a variable is mutually exclusive when it cannot occur at the same time. For example, when jogging, you cannot jog backwards and forwards at the same time. A mutually exclusive variable is something that cannot happen at the same time. And a criminal justice example would be one person not being able to be arrested for the same crime at the same time, but in different places, right? Someone can't physically be in both places at the same time committing the same crime. Maybe if it were like a technological crime, but even then you can't do it. And a coin toss is another good example because you can't have heads and tails at the same time. So most of our variables we want, all of our variables we want our measurements to be mutually exclusive. Exhaustive. An example for CJ that demonstrates both exclusive and exhaustive variable is grouping those participating in a survey by age category. It is mutually exclusive because no one could appear in more than one category. It is also exhaustive because the age groups cover the entire range of the population ages. That's a great example. So someone else provided some feedback that variables need to be exhaustive so that all possible outcomes can be determined. They all need to be exclusive so that variables are not double counted. So yes, exhaustive is ensuring that we have the full range of possibilities, and exclusive is so that nothing is double counted, so that there's not one unit of time that is covering multiple variables. So an example of an exhaustive variable would be gender. Gender could include not just male or female, but it can also include male transgender or female transgender or any other gender. That was a good example. Rolling a 6-sided die, the events 1, 2, 3, 4, 5, and 6, each consisting of a single outcome, are collectively exhaustive because they encompass the entire range of possible outcomes. Yeah, that's another great example. So maybe you want to post a criminal justice relevant example of mutually exclusive or exhaustive, and that could count as your participation points. So here are the types of data that we might collect or use. There's the qualitative, categorical data, and then there's quantitative and numerical. So I've sort of categorized this into a hierarchy so you all can understand and visualize this a little bit better. And so nominal is like eye color, race, things that we can categorize but don't have any inherent value in the type of categories. Like blue eye color is not better than brown or whatnot. It's instead just a descriptor. Ordinal is, there is some type of hierarchy, but it's not very technically defined, right? So when we're talking about a Likert scale, which a level of satisfaction, I'm very satisfied, somewhat satisfied, not satisfied, neutral, and then the opposite spectrum on that side is a range, but it's not super defined. Like scientifically, someone, if we compare someone who is highly satisfied to somewhat satisfied there, and we get multiple people in those two categories, they may describe it a bit differently. So it's not as scientific as an interval or ratio variable where there is the distance between the space actually means something that's tangible, that's consistent. So the reliability of multiple people saying, I'm somewhat satisfied, is less reliable than if we were to be saying that multiple people said they're 25 years old, right? When they say they're 25 years old, we can look and triangulate that data and it makes logical sense. We can construct time across it, and the distance between 25 and 24 is the same consistently every time. We can count the minutes and hours, but when we're talking about level of satisfaction, we can't do that as much. So there is some issues with reliability. And that goes for other Likert scale type variables like a level of satisfaction and agreement spectrum. Also frequency. So if we're counting the instances in which something occurs, also counts as frequency and is ordinal because there's an inherent hierarchy or logic to it. And so the quantitative numerical, which is more reliable, is more valid, are interval and ratio. And we have gone through some examples of that. Temperature and age are good examples of interval and ratio. We have crime rate and income. And so this is another visual which I thought might be helpful. So ratios have a true zero. Interval and ratio have equal intervals. Ordinal, interval, and ratio have a natural order. And anything that we name is a type of measurement, right? So nominal, ordinal, interval, and ratio are all named. And so you see here how we get closer and closer and closer in specificity and also in the validity, in the reliability of our types of variables. And so this is helpful in thinking about how each of these categories have some types of characteristics that overlap, and sometimes they do not. All right, so what is the best measure of central tendency to analyze these types of measurements with? So nominal, we're gonna say the mode, right? Because we can't take an average of eye color or major or race. That's not, it's not a quantitative measure, so we can't average the numbers of it. There are no numbers to average. So instead we're gonna do mode. The mode and the median are often good measurements of central tendency for ordinal variables. And then when we're dealing with quantitative, we can use the mode, mean, or median, depending on what we're interested in. So, but most likely it'll be the mean. So an important point to note is that you can't convert a lower level measure to a higher level one. So the highest level measure that we have is a ratio, right? And so if we're trying to convert a nominal, an ordinal to a nominal variable, we lose information, right? We lose the hierarchy that exists between those things. If we're trying to convert an interval ratio into nominal, we lose information as well. So you see that the ratio provides us with sort of the most information. It's usually incorporates time into it. With income or crime rate, we're thinking of within a specific year, within a specific area. With income, we're thinking of a specific person who has a certain amount of money for a particular time period, usually a year. And so this is just sort of a helpful table for thinking about whether or not you can convert these types of measurements into others and how much information we lose if we do. So you're probably asking yourself, why would I ever want to lose some information? So sometimes you might want to go from ordinal to nominal if we're testing the ordinal nature against more quantitative metrics. So risk assessment, ranking, and actual crimes committed. So risk assessment is nominal. There's a level of people who have higher risk are theoretically supposed to be more likely to commit crimes if they're released, right? And so we might want to change the nominal and the ordinal information into a more nominal situation. And so we might also want to create an interval variable into ordinal if we want to create ranges or typology. So let's say there was an example someone talked about of age ranges, right? So maybe we recognize that there's some generational differences that we're wanting to understand. So rather than measuring age in particular, we're turning age into an ordinal categorical variable of adolescent, teenager, middle-aged person, elderly. And so that's a reason why we might want to lose some information, is if we're very interested in the generational differences. There's also, if we want to, we might also do a similar thing to ratios. So we might want to understand lower class, middle class, upper class rather than income, right? We might want to put an ordinal space onto it so that way we can see the distinctions between categories and sort of create like cohorts of people, like cohorts being people who all are theoretically supposed to experience the same thing. So people in the lower class might experience a similar lifestyle or whatnot. So we might want to change like the measurement data we collect of annual income from 25,000 to 50,000 and put it in one category rather than analyzing the numeric aspect of it. So rates versus ratios can sometimes get a little bit confusing. And so rates are actually types of ratios in which the units of analysis are different. Time is usually incorporated as well into rates. So crime rate is the number of crimes per population in a year. So we have multiple sort of conversions there. Interest rate is the percentage of larger monetary amount added over a year. So we have a percentage of a something else over a year. Often creating rates is helpful for comparison, especially in criminal justice. So a lot of times we're dealing with rates. So we might want to measure over policing, expenditures of government, or demographics. So like the percentage of people of color in a particular area, or the percentage of people in poverty in a particular area. A lot of times when we're studying criminal justice, we're dealing with communities, we're dealing with neighborhoods, and we often very frequently deal with rates then. So composite measures, which we talked about earlier, are turning a compilation of variables into a categorical variable or ordinal variable. So this could be helpful for social science research to operationalize theoretical concepts that are too abstract for us to visually see. So for example, collective efficacy is a type of measurement that was developed to try and operationalize social disorganization. Because what is social disorganization? So many people think of so many different things, like we've talked about in prior lectures. So collective efficacy is instead an aspect of that, which is somewhat abstract. It's the likelihood that people are willing to intervene in a particular scenario. And so there are a bunch of measurements that, which if there are a bunch of measurements, that means there's a composite. It's composed of multiple things that are indicating the level of collective efficacy. So from that composite, we create an ordinal variable in which there's a sort of order to which there's high collective efficacy, low collective efficacy. And from that rate, we can determine, okay, how does collective efficacy influence crime? Another aspect might be risk assessment, which we sort of talked about prior. So high level of risk, lots of times I'll get into an example of a specific risk assessment. So I'll just pause for a second, won't get into it yet. So collective efficacy was measured by residents being asked about the likelihood that their neighbors could be counted on to take action if 1, children were skipping school and hanging out on a street corner, children were spray painting graffiti on a local building, children were showing disrespect to an adult, a fight broke out in front of their house, or the fire station closest to home was threatened with budget cuts. So residents were asked things about their neighborhood. So it's residents' perspectives of how their neighborhood is. And so there's multiple questions and there's a scale by which the likelihood is determined. We're thinking with a Likert scale again. And so there's a range and there's a composite score, which is composed of all the answers to that question. One individual gets that. And then there's averages of neighborhoods based off of how the people who live in that neighborhood view their neighborhood. And there's some issues with reliability, right? Because people might perceive their neighborhood to be different than the researchers see, right? Or people may not commit crimes in neighborhoods in which they live. So there is some issues with reliability, but it's still, even though it's a measure that's not perfect, it still allows us to measure something that's so abstract like social disorganization theory. So instead of just thinking about social disorganization, now we have a smaller component which we can measure, which is collective efficacy. The public safety assessment is the risk assessment tool that gets used in New Jersey. If you're interested in that, I have done some research on that, happy to share with you all. But there are each of these specific gray areas is part of the risk assessment score. So the 2, failure to appear in new criminal activity, is a 1 through 6 that you get. So for each of those individual measures underneath it, it helps compose the larger failure to appear variable. And so as you see, a lot of these are dependent on criminal history. So basically, if you get yourself involved in the criminal justice system, then you're more likely to be viewed as failing to appear or as having new criminal activity in the future. And so the only thing that's not related to like how a person has prior engaged with the criminal justice system is age, right? And so a lot of studies have shown that adolescent, young people are more likely to commit crime than older people, right? And so that's why that also gets incorporated into it. And then the new violent criminal activity is like a number that gets composed, and it's either a flag or a not flag. So it's a binary variable. It's a yes or no. They're likely to have new criminal activity. And so you see that all of these measures underneath the larger measure composes are what compose the composite variable. And so these things determine the recommendation for monitoring levels. So if you get a 0 across these measures, then you're just released without any conditions of surveillance or any required reporting. If you get over a 4, then you are recommended to be detained. And there's this whole court proceeding that occurs and is framed by these recommendations. Alrighty, so getting back into sampling, sometimes, and that's another, I want to connect these two things. So risk assessment scores are often very controversial because the research that they're basing themselves on is not like we can randomly assign people to be detained or not detained, right? That's not super ethical. So we're limited by our sampling, by our research design, and therefore a lot of the measures that compose the composite are within the criminal justice system itself. So it's sort of like our data is composing itself in a way. If that doesn't make sense, don't worry about it. Just sort of my own thoughts there. So composite measures help us get around certain types of not being able to operationalize definitions in a very tangible way, allows us to measure something that's more abstract, but those things are still like have a lot of error in them. And so sometimes we can get an entire population, like universities have data on everyone who is matriculating into them, right? Everyone who's going to the university, their students, employers, others. So that might be helpful for descriptive statistics, but we can't necessarily make generalizations about students all across the US. So if I were to have demographic stats on like 40% of Rutgers, and I'm making this up, I have no idea, 40% of Rutgers University students are first generation, or 30% are of immigrant background, or something like that. I can't make that generalization about students throughout the state or students in general in the US. These things, usually when we have data on an entire population, it's very place and context specific, so we can't make generalizations. And generalizations are sort of findings about a particular likelihood that something could occur. So this makes there limited options for research questions. So if you wanted to do research about the demographics of Rutgers University, you could talk about certain things, but your generalizability is limited within the space that you're in. And so this is a little preview of types of sampling to help us be able to actually generalize when we are limited in being able to get the entire population. And so there's probability versus non-probability sampling, and probability sampling means that we can make generalizations about a larger population that we're sampling from. So these types of sampling strategies: simple random, systematic, stratified, multi-stage clustered, and disproportionate. I know it sounds like a lot of jargon, but we're going to get into it in the next lecture, are all types of sampling where we can make firm generalizations, and we can do that because of statistical theory, which I'll get into not too much in the next lecture, but just so you have a basis of it. Non-probability sampling is more exploratory. We cannot make massive generalizations about the sample element that we're considering, but we can say some things about it. We can say, it doesn't mean that it's not valid forms of research. It just means that we have to qualify. And by qualify, I mean we need to sort of be transparent that there are some limitations about the generalizations that we can make. And non-probability forms of sampling are convenience sampling, purposive, quota, and snowball. And we'll get into this entire graph in the next lecture.